Hello and welcome back to the first lecture, Introduction to Artificial Intelligence. In this lecture, we will cover what is AI, brief history of AI, types of AI, and many more things along the way. So let's start. To start off this lecture, I will start with a very famous quote from Fai Li, where she says, AI is the second machine age. The first machine age was about automating physical labor. This age is about automating human cognition. So if you remember, Industrial Revolution started replacing humans with machines, with when Henry Ford first bought conveyor belt, right? And in this age, we're trying to create a piece of technology which is equivalent to human brain. How cool is that? A machine, a technology which can think like human, reason like human, act like human, and whatnot. So on that strong note, let's start. So the very first question what pops up in your head is, what is AI? What is artificial intelligence? Artificial intelligence is the field of science concerned with building computers and machines that can reason, learn, and act in a way that would normally require human intelligence. So, any task which does not require human intelligence now is called artificial intelligence. So, let's say, for example, you search what is a cake? Is it a eating item? Is it a chemical? Is it a subject? It is an object? What it is, right? So that requires a human intelligence, and you have to cognitively search and cognitively analyze what is a cake. But now artificial intelligence is becoming so smart that it can understand what you're asking. So let's say if I just throw this on chat gpt, what is a cake, it will tell me it's an eatable item, it is made up of flour, it is sweet and whatnot, right? So that's how far we have come. It is almost like a human, right? And we will be soon coming to a point where artificial intelligence will be more smarter than humans. So it's just crazy, right? So let's understand AI with an example for better understanding. That is the color yellow? So let's say if I throw this question to a human, he or she will first analyze what question it is. He will listen to properly and then process the question, that is the color yellow? And then the brain will throw some patterns. It will go through a memory, and it'll recall what does the color yellow look like, and what is the yellow first at the first place. Is it a color? Is it an object? It is a living thing? It is a non-living thing? You will just go through all sorts of filters, right? And then you'll finally response yes. But all this happens in milliseconds. It happens in so fast fractions of speed that you can't calculate. That's how fast your brain is. And these things now even artificial intelligence can do. So let's say if I took this circle of yellow color and throw it on artificial intelligence model, it is capable to understand whether the color is yellow or not. So that's how smart it is. So isn't it cool, right? Even a human can tell, even an artificial intelligence can tell. So it has almost reached a level of intelligence, right? Some of the prominent areas where AI has already been active, that is self-driving cars and humanoid robots. So I did not tell you which symbol is this. It is the Tesla symbol. And self-driving cars use a lot of amount of data, a lot of amount of machine learning, a lot amount of artificial intelligence in backend in order to run, in order to perform such tasks of self-driving. And if you remember her, she's Sophia, a humanoid robot. So under her hood, there's a lot of artificial intelligence packed in, which helps her respond like human, talk like human, think like human, and maybe reason also at a certain point. So the conclusion over here is artificial intelligence has achieved a level of intelligence like humans, but it is not very accurate and is not smart as humans, right? So that is what is AI. Now that we have understood what is AI, let us understand the brief history of AI. Where did this all start from, right? So the very first year where it started off was 1950. Alan Turing publishes Computing Machinery and Intelligence, the first paper. As you can see in this Wikipedia snapshot, Computing Machinery and Intelligence is a seminal paper written by Alan Turing on the topic of artificial intelligence. So he was the first person to basically bring this into light and into the whole public, that artificial intelligence is this thing which exists, right? And after this, the second prominent year where things pulled up was in 1956, when John McCarthy coins the term artificial intelligence. Yes, you see this person with the computer, he's the person who coined the term artificial intelligence. So if you're using the word AI every day, it's because of this person, right? So after 1956, the next big year was 1967. Yes, this is a very big year. The reason I tell you is because this is the year we discovered neural networks. Frank Rosenblatt builds the first Mark I perceptron, the first computer based on a neural network that learned through trial and error. Yes, you see this person, he's Frank, and you see that jumbled wires, that's basically a neural network. Uh, Composition of how neural networks work is basically you have a lot of neurons connected to each other, and on one side of it there's a huge amount of data which you given, and on the other side there is a response. So you can zoom out with this and understand this way. This the modern neural network works similar to this. You give a data, it understands the features, it breaks it down into numbers, into pixels, and then it learns all the features. And let's say if you give a question on that data, it will give you an output. So that's how neural network works. If you want to read more about it, you can just go on Google and just type Mark 1 perceptron. There is a huge article on it, and you can explore this thing by yourself. So it's very interesting because this is where all our ideas of neural network comes from, right? So after 1967, the next big year, which was 1995, when Stuart Russell and Peter Norvig published their first book, Artificial Intelligence: A Modern Approach, which becomes a leading textbook in the study of AI. So you see that textbook, that's a 1,500 pages huge textbook. Yes, you heard me right. It's free on the internet. You can just go to the website. I have dropped the link over here. And this is the first textbook, a proper technical textbook, which contains a lot amount of study and research about AI, right? So after 1995, the next big year was 2004, when John McCarthy writes a paper on what is artificial intelligence. You saw that person in 1956 who was holding with a computer. That same person wrote the artificial intelligence paper, who also happened to coin the term artificial intelligence. So after 2004, next big year was 2015, a long jump. We have come to Baidu's Minwa. It's a Chinese company where supercomputer uses a special kind of deep neural network called CNN, convolutional neural network. We will talk about CNN in the further episodes and in further lectures where we dive deep into what is CNN. So wait for the lectures to come up. So for now, it's a deep neural network. It's basically a type of neural network which is only used for image recognition and visual data. So Baidu Minwa was a company in which the supercomputer used this neural network to perform certain tasks, right? So we have all the way come from 1950 to 2015. And the next big year after 2015 was 2016. A year later, DeepMind's AlphaGo program, powered by Deep Neural Network, beats Lee Sodal, the world champion Go player, in 5 game match. So can you imagine AI beating a human being? It has become so smart that it is capable to compete with a human, and in fact, it has even beaten it up. So at this point, we have made the AI so smart that it is able to compete in a full-fledged game and outrun a human being. Crazy, right? So after 2016, the next big year was 2023, which is very recent, and a rise in large language models or LLMs such as ChatGPT. Now, those of you who don't know, between 2016 to 2023, the ChatGPT was going into the build phase. There's a lot of ChatGPTs. It is now currently the ChatGPT 4 right now. We are currently using it, but earlier there was GPT 3, and more iterations of that which went through these years, and advancing of AI. So yes, we have all the way come from 1950 to 2023, and the rest is a history. We are yet to see what the AIs can do. So yeah, this is a brief history of artificial intelligence. Now that we know what is an AI, now that we know what is the brief history of AI, let's move up to something different, that is types of AI, right? It's very important to understand what are the types of AI that exist so that it is easy for us to differentiate difference between them, right? So the very first type of AI is artificial narrow intelligence, also called ANI. Artificial narrow intelligence is a type of AI that is better than humans in one specific task. For example, autonomous driving. So you see ChatGPT right now, it is only good at question and answering. So if I give a question to ChatGPT, it can answer almost like a human. That's because it is trained on a specific task to answer, right? And similarly, we can train various AI models for specific tasks. We have specific AI models for chatbots, we have specific models for education, specific models in healthcare, for image classification, for video prompts, and many more things. And that's ANI. And to be frank, we are living in an ANI era where it is only possible. The rest too, what you see is AGI and ASI. We are yet to discover that. We are yet to come to that phase. So the next type of AI is AGI, artificial general intelligence, capable like humans in every task. So it is almost like it can perform tasks like human, but it is not smart and not better than humans. So right now the AI is only capable of doing one single task. Sooner it will be able to do multiple tasks which a human can also do, right? And after AGI, we have something called ASI, artificial super intelligence. Now, this is completely speculative. It is completely hypothetical because we it can outrun humans, right? As you can see that it is better than humans in every task. So can you imagine a century where artificial intelligence is completely smarter and 100x better than humans? So it's very scary to see that and very scary to imagine that also. But we have to see a long way to go to see what happens in ASI. So yeah, these are three types of ASI: ANI, AGI, and ASI. Now let's understand them in a little bit more depth, starting off with ANI. So this is the most common type of AI and also known as weak AI. Now, why do we call it a weak AI? Because it is only trained and instructed to perform a specific task. AI excels at performing specific tasks exceptionally well, right? So if I give an AI to, let's say, question and answer, it can do extremely well and it can even outrun a human being. But if I tell an AI to reason like a human and also analyze like a human, I think it will fail. It will very big time fail because a human can perform multiple tasks, but artificial intelligence cannot because it is not yet reached that optimum level of optimization. So we're yet to see that, and that will be basically in the in the AGI phase, right? So get some examples of ANI is image recognition software. Let's say you throw an image, it will be able to identify what kind of image it is. It's a cat, it's a dog, and that's basically where we can use CNN, right? As we discussed in the brief history. Again, we will dive deep into it into the future lectures. So stay tuned for that. And next is spam filters, chess playing programs, self-driving cars, tic-tac-toe games. So these are the places where ANI can be deployed, and it can be very, very good at doing this such tasks because it is just trained on one particular task. So no, it did not jump around doing multiple tasks back and forth, right? So now that we have understood what is artificial narrow intelligence, let's move on to the next one, that is AGI, artificial general intelligence. This is the hypothetical of AI type of AI would mimic human intelligence. So as you can see the word mimic, that is, it is trying to be like a human. It's not a human, but it's trying to be like a human, right? Capable of learning, applying knowledge across various fields. AGI does not currently exist. You heard it right. AGI does not currently exist. It is a field where we will eventually reach, but we are yet to reach there. So it's basically it's trying to mimic humans, right? So then now we know what is ANI, now we know what is AGI. Let's move up to the next one. What is ASI? ASI is purely speculative at this point. As you can think, if AI gets better at humans in every single task, I don't think humans. Why do humans need at that point, right? So it is a space where we have yet to. It's too early to make a comment there, but we have to see how this space turns out. So we should wait for it. But yeah, these are the three types of AI, right? Now that we know what are the types of AI, we know what is the brief history of AI, we have seen what is AI, let's move to the next part, that is, how does AI work, right? So it's my duty to make you understand the fundamentals of AI. How does AI work from first principles? What is the logic going behind it, right? If I'm throwing a task, how is it able to perform a task, right? That's the question, right? How is ChatGPT working in the background? Of course, there are more technical things behind, but an overview of logic, what it looks like. So to start off with, AI works with combination of algorithms and data, essentially mimicking and learning a process, right? So imagine this way. Let's say you got a new pet at your home, and you're training the pet for various instances. For example, you take a ball and you throw the ball. Basically, you're training the dog to get the ball back to you. And what is that? That's basically training. And the ball, what you're showing to the dog or the cat, is basically the data, right? You're showing the actions, you're showing the wordings, you're showing the dog is able to listen you, it's able to process it, it's able to remember it. So that's the data you're giving it, and that's also kind of a training you're performing simultaneously. And that's how AI is almost like an training like a dog, right? So the very first thing is data. Data is king. This is one of the new types of oil, that is data. AI systems are trained on massive amounts of data. You just can't even imagine how much amount of data can go to train a model to perform a specific task, right? This data can be text, images, videos, or any other format relevant to the task. So, to give an overview, let's say I train a AI model for a tic-tac-toe game. I need to give the model every possible solution of tic-tac-toe. So, let's say if an O and X and O, I need to give all the possible scenarios. So, just imagine the number of possible scenarios you can create, and you have to give all of those data to the model, and then the model should be able to reason it, and then the model should be able to do a fair judgment and choosing the right one. So a lot of things goes behind it, but data is the key here, right? I need the data to train the model. So the very first thing and the to the training or the performance of how then AI performs is data, right? So after the data is done, we move to algorithms. So I know you might have studied this algorithms in your previous classes, or if you're someone who understands the tech industry, who understands tech very well, you know what algorithms are. Right? It is a set of instructions. So behave this way. Let's say I tell the dog to go and get the ball. That's the instruction I'm giving to the dog, right? So similarly, you will give an instruction to the model. You will tell the model what to do and how to do, right? So there are two types of algorithms. One is machine learning, one is deep learning. Again, we will discuss these topics in depth in the coming lectures, so stay tuned for that. To give an overview, machine learning is basically we need not explicitly program it from outside, right? So generally, if I have to, make a tic tac toe gameplay, I have to explicitly program it to perform the next move. I have to tell what move to be done in the next move, right? So it's a lot of training, lots of code going inside there. But for machine learning, it's not that way. It basically learns from the data. And in deep learning, it's a subfield of machine learning. Basically, it goes in depth more. It's more like a neural network and a lot more things going behind the scenes. So again, we will discuss that in the upcoming lectures. So stay tuned. After algorithms are done, after data is done, we move up to the next part, that is training, right? So this is the most crucial part. The AI model is exposed to the data and algorithms and analyze it during the training, and the model is tuned to improve its accuracy, right? So when you tell your dog to get the ball and you throw the ball again and again, you're basically training it. You're training it for that particular task, that is throwing the ball, and you have given the data, right? So a lot of things going simultaneously, and all of this clubbed together. That is how AI works, and this works in very quickly, right? So the moment you put the query on the prompt, just get it right, because it's very quick. So yeah, this is what the basic functionality, and this is the basic fundamentals of how AI works. So now that we know how AI works, let's move to the next part, that is a diagrammatic workflow of AI. This is basically to give you a quick small tour of how does the AI work. So starting off with understanding the problem, you again, as I mentioned, it is trained for a specific task. So once the problem is understood, then we prepare the data, right? For the problem, we need the data, right? And after preparing the data goes to converting, right? So what is converting? Basically, if you are from tech industry, you understand that computers understand from in numbers, binary numbers, right? So the data has been broken down into various chunks of numbers, a huge amount of numbers that basically computers will understand. So the data has been converted. Next, it moves to processing. Basically, at processing, it filters the data. Assume it as a net, where it basically filters the what is correct, what's wrong, what is redundant, what is not, and many more filters behind the scenes. So after this processing stage, it moves to training stage. Basically, the machine gets the algorithms, we give sort of instructions, and it starts training on that data, right? Once the training is done, the next part is evaluating. Test whether the model what you trained is correct or not. You have to perform certain tests, and you perform that by various metrics. So that's evaluation. So once the evaluation is done, it moves to the next phase, that is inference and deployment. So at evaluation, you're just testing it, right, on metrics, but in deployment, you throw it on a real world scenario. You just give it a any world real world scenario and try if the model is performing in the real world and or not, right? And the last phase, that is pretty much common for any software that exists on the internet: either you retire the software, either you replace the software. In AI's case, it is basically fine tuning it, making it more accurate, adding more data, making it more precise. So that's basically like you're replacing the older version with a new version every time. So this is a whole diagrammatic workflow of how the AI works. I hope this makes it easy for you to understand the whole flow and the structure of AI, right? So we have covered a significant amount of thing so far in the lecture. So next is real world applications of AI. Now, of course, you AI, we need to think, right? What are the applications of AI? We have built-in model, right? We need to think where can AI be used. So I know that I could have added more things over here, but let's understand from an AI application point of view, an industry, and a common example where the company is using it, right? So medical diagnosis. So imagine in healthcare industry, you can use AI to perform tasks which usually require a lot of tests, a lot of surgeries, and a lot of testings to be done behind, which is very costly to be very honest. So if AI can reduce the cost and it can make it more accessible, it is a very win-win situation for the healthcare industry. So best example over here is Google Health. Their AI Vera analyzes mammograms to identify potential signs of breast cancer. So how cool is that? Now when AI can analyze whether the female is suffering with a breast cancer or not. Earlier it would require a huge amount of tests. They need to go under medical tests to understand whether the female is under breast cancer or not. And now in a piece of technology, it can do it very quickly, right? Next is fraud detection. Can you imagine your finance app telling you whether the transaction what you're doing is fraud or not? That's basically done by PayPal. AI algorithms analyze transactions in real time to prevent fraudulent activities on their platforms. So how cool is that? That AI is been also used to detect frauds. So you save your money, and hence there is no scam happening with you, right? Self-driving cars. I need not give a very good example. It's Tesla. Man, Tesla has been all over around. So a good example of it is Tesla, and also you can see Waymo. That is develops self-driving cars technology using combination of lidar and radar and cameras and AI. So that is where a good use case of AI we are using on self-driving cars. Hence, we can save lives, and we can save the human population, right? Recommendation systems. I think this is the most easiest way to communicate through AI, which we are doing it on day-to-day basis. In fact, if this video popped up on your YouTube feed, again, there's a lot of AI doing in the backside, which is pushing this video top to you so that you can view it. So that's the easiest way to communicate, right? So recommendation systems, again, retail. Amazon recommends products to users based on the browsing history and past purchases. So if you see that funky little bag coming up on your feed, or you see that smartphone coming up on your feed, all thanks to AI, because they are in the background pushing the data and pushing all those things to you so that you make a purchase, right? Again, we have chatbots, customer service. You would have seen in this modern banks, if you consider these modern websites, they have chatbots deployed for tasks, for simple tasks. For example, if you have a query about your transaction fees, or if you just want to know how is the transaction going on, or what are the transactions you have done in the last few months, maybe a chatbot will do that. Earlier, you require a proper human behind the screen to understand that and address that, right? So now chatbots can do that. So these are some of the applications. Of course, there are multiple applications that AI can do, and to be honest, AI can disrupt a lot of industries. It can be a lot of job creations and also a lot of job failures. So we yet to see that. And comment down below, what do you think, where what industries where AI can come up and show up. So that's a very interesting thing to see. So now that we know what is real world applications of AI, let's move up and let's do a quick recap of what we have covered so far. So we covered what is AI, the small definition of, and surface level understanding of what is AI. We moved up to brief history of AI. I gave you a quick snapshot of where it all started from and where have we reached so far. And after that, we discussed types of AI. There are three types of AI: AGI, ANI, and ASI. And then we worked with how does AI work, right? The fundamental of AI, the logic behind how does the AI is working in the background. And the latest one was real world applications, where I showed you what are the possible applications with AI. So that we have covered a significant amount of things in this lecture. Challenges of AI. So the very first challenge that comes up is bias and fairness. AI systems can inherit and amplify biases in the data they're trained on. So let's say if I train a chatbot that detects only lies despite you telling the truth, you will feel cheated, right? That is because I have trained the data to tell only lie and detect only lie, right, despite being truth or not, right? So that is basically bias and fairness. If I deploy this on a government sector, imagine the amount of damage it can do if it is biased, right? If it is unfair, right? So that is the first challenge we have to solve with AI. The second challenge which comes up is explainability and transparency. So if I give an AI system to reason, right, this is where human intelligence comes in. If I tell a AI system to tell me the reason behind how it generated the response or how the logic works, I think it will fail at times. Why? Because it doesn't know how to explain it. It doesn't have the ability to explain like a human. It doesn't have the ability to understand like a human, right? And it is not transparent, right? If the system is not transparent, if it is not able to tell you the response, or it is not able to give you a conclusion of how it came to a conclusion, or how it came to that response, you will feel again it's cheating, right? It is almost like uh, it is almost like a lie, right? So often referred to this as a black box problem. AI models can be difficult to understand the decision making process, right? So back in the back end, there are a lot of algorithms. If the algorithm is messed with, it will not give you a very solid response, right? So that is second challenge we have to work on, and we have to collectively evade it so that we can make the AI more safer and more better for people. The third challenge is data and security. Oh boy, this is a very big challenge we have to focus on. That is security and privacy. Nobody will like if the data is being leaked, if the security is not, if the data is not secure enough with AI systems. So data and security is a very big concept in itself. If the data has been used, which is not secure, which is not, which has been, which is supposed to be private, right? So for example, government data. If the government data is not secure and not private anymore, it is breaching the privacy, right? It's breaching security, right? So that is one of the challenges we have to face, and we have to also solve it, say side by side. The next is job displacement and automation. So this is one of the big buzz thing that is all around. You also might be thinking that will my job go away with AI? Of course, there can be a certain degree of jobs vanishing away, but you and I have to always upskill ourselves, have to learn more, have to keep up with this AI race, and that's the only way out with this technology. So this is a very big threat. Of course, as you saw in the industrial revolution, where humans were replaced with machines. So imagine earlier humans were doing it all manually, but once the conveyor belt came, a huge amount of humans were just vanished. It's because machines are so capable and more efficient than humans, right? So that's a job displacement and automation. So as a we have to make more policies and security, more laws, so that we can work together and solve this problem. Next up is safety and control. So this is a very important point to be noted, because if these systems get on with children's, right? If we give the systems to children's, or we give this systems to people who are hackers, who can hack the system and can override human values, it will be a very big threat to humanity, and in general it will be a huge loss, right? So this is some of the main challenges. Of course, there are multi more challenges behind the scenes. We have to address them as well, but just to give an idea, these are some of the challenges we need to address and we need to solve side by side. So you and I together have to contribute to this. So now that we know what the challenges of AI, let's move up to the next section of this lecture, that is giving you an example of the challenges we just discussed. So if there is a bias, right, how will it look like? An AI algorithm used in loan application might favor applicants with higher incomes, unintentionally discriminating against low income borrowers. So that is, again, you will definitely feel cheated, right? So and of course, that's a why is there a discrimination among people, right? Why should a AI system, what rights does an AI system gets to discriminate between humans? So that's basically bias. Explainability: an AI system flags credit card transaction as fraudulent. So credit card's whole system is that you can borrow money from the bank, but an AI system tells that you're doing a fraud. You're just transacting and you're using money and you're just running away with it, you're not paying it. So that's unfraud, right? So that'll basically spoil your whole experience of using credit card, and you'll just feel that it's no point of using a credit card, right? So that's explainability. Data security and privacy, right? A large data set used to train AI for facial recognition might contain private information like individual's home address. So you won't be happy if your home address is revealed on public level. Everyone knows where you stay. And imagine if a high personality individual gets leaked his data, gets leaked his in a home address, he won't be happy with it, right? So AI can do that, right? And job displacement, as I said, for the one of the examples was industrial revolution, and now here we see AI is replacing for writing, content writing is now even able to generate image to image, so we need not a lot of the one of a certain chunk of graphic designers are getting replaced. So that's where job displacement comes in. And safety and control: if the AI systems are not very secure and controlled, it will cause disaster. Let's say if in a self-driving car there is small error while driving, it will take your life, right? So it will be very disastrous to think that your life is just taken because of a small error in the AI, and because it's not safe and secure, it's not controlled, so you'll lose your life. So these are some of the examples I wanted to walk you through, because I also worked with a challenge. So it's very important for you to understand what the challenge and what the example will look like. So you can make a figure, or you can make an idea of the example, right? So we have covered a huge amount of things in this lecture, and we're almost coming to the end of this whole lecture. And the next part of this is future of AI. That is, we discussed everything about AI, but it's also important for us to see what does the future of AI look like, right? So AI will be everywhere. Of course, at this moment, you see ChatGPT. You use ChatGPT the most, right? I myself started using ChatGPT more than Google search. So AI will be everywhere, right from your smartphone to your home appliances, to your cars, to your home, everywhere, and that will be an integral part of our lives. And the next part where AI will be is smart machines. So right now, you see the robots, right? You see those self-operating robots. Even machines will start operating by themselves. So if a car can self-drive itself, even machines can do. So you see, the machines at your homes, the you can bring those machines and they'll be all automated, right? They'll be completely be run on AI, on artificial intelligence, and those that will be a thing to look in the future, right? Just imagine those hypothetical scenario of a home where everything is controlled by AI. Next up is industrial revolution. Again, as there was a machine age revolution, there will be an AI revolution where AI will be in-depthly injected in all the industries, and it will take a big evolution of things going up there. We already see those automatic robots. Just a more advanced version of it will be using AI there, and I think less and less humans will be start getting into the industry space, right? And the next thing where I see is ethical crossroads. So basically, towards the future, right, the challenges what we discuss right now, the things what we think which will ruin the AI, right, the we need to work on it. it will slowly get better and best with time, because people are working, there are research teams and there are companies who are dedicatedly working to solve the challenges. So the whole purpose is to make AI more worthy, secure and safe to everyone to use. So yes, this is the future of AI look like. So yeah, this is a brief overview of what the AI will look in the upcoming time. That being said, it's time to conclude this whole lecture. That is, AI has a potential to revolutionize numerous fields from healthcare to transportation. I need not tell you, you can just make a rough ideation of what the AI will look like and which industries will be coming in. So, right from education to healthcare to retail, every single place. And I think it's a moral responsibility of both you and I to contribute together into this AI space, right from the data, right from safety and the challenges, to help make AI more secure and especially accessible to people who can use it for a better use case, right? So the potential of benefits of AI are enormous, and we have the opportunity to steer its development in a way that benefits all humanity. Again, this is a quote from Fai Li. So it's in our hands how we steer the AI. If we are not cautious with development of AI, it might be a disaster. It can be a huge, dinosaur age kind of thing where it will just completely make the humanity go worse for all time. So we have to be very careful in staying the direction that is towards more positivity, the humanity's point of view. And next up, I have a personal recommendation for you. That is, please upskill yourself, learn as much as you can, and try out things. The challenges is to stay on top, right? If you're not learning AI, if you're not staying up with the curve, of course you will get replaced, and that's a very fearful thing to think of, right? So the only way to beat is educate yourself, and of course lectures like these will help you with this thing. And last but not the least, that is, the margin shall be keep going up, so should you. All the best. So keep excelling yourself, keep educating yourself. That's all from my side, and this was the whole lecture of introduction to AI. And thank you so much for joining with me on this lecture. And as promised, we have a resource tab for you, which is basically all the important resources where, especially, I have also learned myself, and you can also too learn on your self pace. These are some of the websites. I'll be linking them down in the description. Feel free to go and explore them by yourself, learn from them, and of course, they have a lot to tell you, a lot to teach you. So, of course, you can go from basic to intermediate and more, of course, with time, advanced level. So this is a resource tab. And with that, we'll wrap up the lecture one. Thank you so much for joining with us. And there'll be more lectures coming up with on LLMs, machine learning, neural networks, and many more topics in the future lectures. So stay tuned, subscribe, and the best way to support us: drop a comment, like, and tell me what you want to talk about me, what you want to give me feedback. Any feedback is appreciated. And with that being said, I'll take our sign off. Thank you so much, and we'll see you in the next lecture. Bye bye.